Okay, we are back and we're going to do this one problem on converting moles to a number of atoms. So if it is in a compound, you have to take an extra step. Again, if it is in a compound, you have one more step. All right, so we're going to take the same steps as we have before. We're going to underline what we are given. So we are given 2.12 moles of this guy. And what we are looking up for are how many atoms are in that mole. So that means we have to find out the number of atoms of carbon and the number of atoms of hydrogen. So we have extra steps that we have to take. Now we have our given underlined, we have what we're trying to get to circled. So now we want to write down our conversion units. And just for a reminder, we're using C3H8. Yep, C3H8. All right, so we know that 1 mole is equal to 6.02 times 10 to the 23rd molecules. It's also equal to 6.02 times 10 to the 23rd molecules over 1 mole. So we have our two options there. We also need to figure out how many atoms of carbon are in our compound. So for 1 C3H8, we have 3 carbon atoms. And I know this because of our subscript. You can also write this as 3 carbon atoms over 1 C3H8 molecule. Now we also need to know how many atoms of hydrogen, but we'll come back to that later. So our first step is to go from our given and get to how many atoms of carbon we have. So we start out with our given, which is 2.12 moles of our C3H8 over 1. We have to pick the correct conversion unit, and because our moles is on top, we can't use our first option. So we also then look at the second one. Our moles are on the bottom. That's the one we need to use. So it would be 6.02 times 10 to the 23rd. That's Avogadro's number. And over that 1 mole. Our moles cancel because there's one on the top, one on the bottom. And we're left with molecules, but we're not quite there yet. So we have molecules on top. We're going to add one more step. We have to go from molecules to atoms of carbon. So we have to pick our second conversion unit that we want. We have molecules on the top for our first guy. We have molecules on the bottom. Molecules on the bottom of our second option. Since molecules is already on top here, we cannot use this first conversion unit. So we will use our second one where we have 3 carbon atoms over 1 molecule of C3H8. That's going to cancel out those units and leave us with how many atoms of carbon we have. So once you do all of that information, you get it is 3.83 times 10 to the 24th atoms of carbon. We're going to do the exact same thing, exact same process, except go to hydrogen next. Now that we have our atoms of carbon, we have to do the same thing for our atoms of hydrogen. So if we start with the same thing that we had before, just a second. We have our C3H8, and again, we're going to write the same conversion factor. So 1 mole is equal to 6.02 times 10 to the 23rd atoms. And we also want to do the same because we don't know which one we're going to need just yet. 6.02 times 10 to the 23rd atoms is on top over that 1 mole. Now we want to make sure we have that second conversion factor that we need. So we know that we have 1 molecule. Whoops, I wrote atom up here. I'm sorry. I'll fix that really quick. This should be molecules. Yep, so we should have our molecules. Here we go. And so we have 1 molecule of C3H8 over how many hydrogen atoms do we have? So we have 8 hydrogen atoms, and we know that because of our subscript. Or we could have 8 hydrogen atoms on top over our 1 molecule of C3H8. Okay, so now we're going to start with exactly what we have. So we have 2.20 moles of our molecule over 1. And just like before, we have to pick the right conversion factor. So since moles is on top, we want to make sure that we pick the one with moles on the bottom once again. So we have 1 mole of our C3H8 on the bottom, and we have 6.02 times 10 to the 23rd molecules on top. And again, we don't want to just stop there. Even though these cancel, we need to go one step further and figure out how many atoms. So if we have molecules on top, we would not use the one on the left because our molecules need to be on the bottom once again. So here we have 8 hydrogen atoms on top and 1 molecule of C3H8. After you multiply straight across and divide by anything that's on the bottom, you would end up getting 1.06 times 10 to the 25th atoms of hydrogen. So now if we were to take the number of atoms of carbon, which is 3.83 times 10 to the 24th atoms of carbon, and how many atoms of hydrogen we have, we can determine our total amount of atoms through simple addition. So if you were to add these two together, let's see what we would get. Overall, you would get a total of 1.44 times 10 to the 25th atoms. We have a ton of atoms. So now we are able to finally answer our question of how many atoms are in 2.20 moles of C3H8. So you can see as we get to smaller and smaller things, we're going to get bigger numbers because we are taking apart those big molecules and finding out what's in between. And again, that is taken through in your notes if you have those, if you want to access those on Rediker. All right, that does it for me this time. See ya tomorrow.